Welcome to HBP MOOC and Micro Credential. The title of the slides that I'm going to show later will be Engineered Field in Earthwork Operation. But I have also uploaded the reading material from an article by one of our prominent geotechnical engineer in Malaysia. He is Dr. Gui. I'm sure you have gone through the paper. I think if you have read the paper, basically you will get the idea of how important is a proper earthwork operation. You know, proper when you bring soil to a site where you want to start constructing your building. It is very important that the soil that is going to receive the building, it is in good order. So that's what we are going to discuss today. I think first I will share my slides. How do we make sure that the earthwork that we carried out before we construct the building is done properly, especially when we talk about importing soil from outside our construction site, and we want to make sure the soil is properly laid, spread on the ground, and compacted and tested and verified. Basically, that's what we want to discuss today. I'm sure some of you have been to construction site and probably have witnessed some of this work being done. Engineered field, we are talking about compaction of soil. Okay. So compact when we bring the soil to the site where we want to, start having the building construction. Definitely, you need to prepare this platform, the earth platform, and then we need to compact the soil. So the compaction is actually an effort that you use to increase the density of soil. When you increase the density of soil, we can get certain strength. So we need this strength to be able to support the loading from the building or road or whatever structure that is going to be sitting on the ground. So compaction is the the method that we use to achieve that. Compaction is basically we increase the density of soil by removing air from inside the soil composition by using mechanical energy. So mechanical energy means you can have certain type of compaction, but whatever it is going to be the mechanical kind of things. So that is compaction. In the case of engineered field, okay, engineered is basically you do something based on a sequence and based on certain scientific expectation for during the work, and also during the output of the work. So you expect something to happen according to your plan. Basically, in engineered field, we will select certain type of soil or certain source of soil or certain what do you call characteristic of soil that we choose from some place, from specific place, then that we have selected, and then we place them and compact them to a certain specification. So this specification will ensure certain engineering performance. So that's why it's called engineered field. If we follow these standard procedures, we can expect the same result, irrespective of when we do it, as long as the source of soil and the sequence of work are the same. So we expect them to give the same performance. So that's why it's engineered field. If you look at the photograph here, this is basically a source of soil somewhere. We may need to bring the soil, to transport the soil to this location to create what we saw here, a few platform for us to put a building on. So what will happen here is that first we need to identify where is the soil, from. When it comes from different place, the soil will behave differently. So we need to identify where is the source of the soil, and then before we can bring the soil to the site to be compacted to form this platform, we need to go through this sequence. This is why I said here construction sequence for engineered field. So the sequence is, first we identify the source, and then we identify the compaction characteristic. How do we do that? Once we have identified the source of the earth or the soil, we take some sample. We take some sample and bring to the lab. And then in the lab, we will identify the compaction characteristic. Why do we need to identify the compaction characteristics? It is because we will use this soil, we will bring the soil to the site and compact them later on. So before we compact them on site, we want to do some testing in the lab by having compaction, by looking for the compaction characteristic in the lab. So in the lab, we have to do something to to identify the characteristic. And finally, that will be explained in certain way. And once we have identified this compaction characteristic in the lab, then we can go to the site, bring the soil, transport the soil to the site, and then we will have what we call trial embankment. Okay, we do some trial site for compaction or embankment in case of for roadway and things like that. So there will be a trial site before we actually carry out the whole work. So this trial embankment or trial site should give you what they call satisfactory result to the target strength or performance that we want in the beginning. Who will tell us what kind of performance? That will be determined by the engineers who design the soil platform. Okay, they will design the platform to certain. They would want the platform to be in certain strength. So in order for us to achieve that strength, we need to do what we call trial embankment on site and test it. After we test it, then we would know whether the field has achieved what was expected in the design. So that is what we call field test. Field test is also definitely will be done for the rest of the project, not only during trial. It will be done for the whole project. If you have read the papers, the test will be done at certain area of field at certain interval. If you are talking about roadway for testing, and finally, somebody has to certify. Somebody has to certify that the work has been completed, the engineered field has been completed according to specification. So the specification is like I said before, is specified or determined earlier in the design, usually in this case by the design engineer who designed the earthwork. But as we work in the construction of the site, so we need to know the sequence, because the engineers will usually come at the final, at the certification. Probably they will be doing monitoring and supervision, but finally they will certify the work that has been completed. So what will happen is that in the first stage here, during identify the soil, let's say I have identified that I have a big hill somewhere for me to excavate soil as a source of fill material. So now I need to bring some sample of the soil from that hill to the lab to identify what I mentioned just now is the compaction characteristic. What kind of characteristic? In this case, in the earthwork field, the characteristic that we would like to identify in the lab is very simple. Usually, it involves two types of testing in the lab. One is what we call Proctor compaction testing. The second is CBR testing. Okay, we will go into detail about the testing. So we do the test after we give them the compaction pressure. In this case, a roller. Okay? A roller will give the pressure to the ground to compress them, and then we do the test later. But of course, these days there are new technology which can also be integrated with the roller itself. While it is compacting the soil, it has a sensor within the roller that can receive signal from the soil or from the ground that you are compacting on how strong it is at that moment. So that is what you can say a live kind of detection. But most of the time, we will roll them first, compact them, and then we come and do the testing. Okay, but of course, if you read the latest paper in earthwork operation, you may find some case study on the use of a roller compactor that has been fitted or being instrumented with the sensors that can at the same time verify how good the soil has been compacted. Okay, and one of my students created a sensor that can be left in the ground, and then you will start compacting the ground. Then the sensor will give you the what I call a feedback on what kind of strength that has been achieved from the compaction above the ground. But you need to leave the sensor in the ground, because once you have compacted them, it will be embedded within the ground. In the literature, you can also find a sensor that can be fit into the machine itself, into the roller, that can also give you the feedback. That one, you don't have to keep them below the ground.